So hello everyone again. So in this part I will talk about the curvilinear motion. If you remember the first lecture, we said that there is a rectilinear motion that comes from the word rectangle. It just goes in a straight line. We have the curvilinear like a curved motion in a curve, maybe circular, it may be just an arbitrary curve. And here we will talk about the curvilinear motion. It is again very similar to rectilinear motion, but here we divide the components into rectilinear ones. Let me show you. The airplane moves, you can see. This is the motion of the airplane. It moves in this manner. And then to find the velocity of the airplane at each instant, what we do is that, okay, so firstly, we know that the velocity is ds by dt. Okay. And then we know from the derivatives that v must be tangent to s, because if you remember, so we have the s, let's say we have the t, something like this one. If I take the ds by dt, it must be tangent. Then we were doing something like this one, if you remember. Okay, that is how do we define the derivative. So similarly here, the velocity is the derivative of the path, and then it will be the tangent to this curve. Okay, or similarly here, or similarly here. Okay, so these are the velocities of the airplane, so at different instants. But what we will do is that we will take this velocity here and show its components. So it will be something like this one. So it will be the x component of it, and then I will write the y component of it. Okay, or similarly here, if I take it out, show it here, it will have the x component and it will have the y component. So it will be the vx, this one is vy, and this one is the vx. Okay, for any point here, any points, you can show the components of the velocity. That is how we analyze the curvilinear motion in rectangular components. Or you can say that as if two rectilinear motion, one in x direction, the other one is in one direction. Okay, so we are attacking the problem by separating the problem into its the rectilinear components, so that it becomes easier to solve. Let's solve it with a given problem. So we have an airplane that moves upward with a velocity of 10 meters per second. So it moves up with a constant velocity, which helps us. The path is like this one. So you can see that this path is given as y is 0.001 x squared. Then the question says that to determine the magnitude of velocity, the acceleration, when the y is 100 meter. So the question is, when y is 100 meter, what is v and then what is a? Okay, so let's solve it. Firstly, we will start with the v. So we said that the v has two components. It will have the x component and then it will have the y component. Similarly, the acceleration will have the x component, the acceleration will have the y component. So y component of the v is given as 100 meters per second. And then always constant. Then the vx, the x component will be that dy by dx. Change of the path with respect to x. I'm sorry. dy by dt. So change of the path with respect to time. So that is the velocity, like the change of distance with respect to time. And then actually here it is the x by dt. So x position. So let me just show you. Object moves this way. Okay. It moves, that is in x direction and in y direction. Okay. In x direction it moves with the vx velocity. In y direction it moves vy velocity. So therefore that vy will be equal to dy by dt, and then vx will be dx by dt. Okay. Okay, now let's try to solve it. So to find the dx by dt, we need to go back here. So the question says that v is, question given as y as 0.001x squared. It doesn't explicitly say us the change of x with respect to time, but it just gives us the y as a function of x. And then to find it, what we will do is that we will use the chain rule. Dx by dy, dy by dt. This is the chain rule. Okay. Dx by dy we can write as the engineers write, which the mathematicians don't like, the reciprocal of 1 by dy by dx. And then that will be equal to 1 by, this one will be dy by dx is 0.001, and then times x squared, it will be 2x. Okay. And then that will be equal to 10 to the power of negative 3, and it will be 10 to the power of 3, and divide by 2, it will be 500 divided by x. Okay, this is the derivative. And then I will replace it back here. So it will be that 500 by x times dy by dt, and dy by dt I just showed here, it is the velocity in y direction. This is the vy, and then that's equal to 10 meters per second, which is constant, times 10. Only problem is the x, and the question helps us that it says that find the velocity and acceleration when y is 100. So I know that y is 10 to the power of negative 3x squared, and if it is 100, I can find the x. Then it will be that x squared will be 10 to the power of 5, and then x will be that 10 to the power of, let me do it this way, 4 times 10. So it will be that x will be 10 to the power of 2 times square root of 10. Okay, or 100 times square root of 10, and if you use your calculator, it will be that 10, the square root of it is times 100, and then 316 meters. So we have the value of x, we have value of 500, and then I can easily find, then vx will be dx by dt, and that will be equal to 500 divided by 306 times 10, and then that will be equal to 500 times 10, divided by 306, and then 15.8 meters per second. Okay, that is the Vx. The question says that find the acceleration as well. So first let's start with the acceleration in y direction. Acceleration in y direction is equal to then d of dt of vy. But I know that vy is constant. The question says that it is 100 meters per second. This is constant. If it is constant, then it is 0. The body does not accelerate in y direction. So let's solve the x direction. So to find the acceleration in x direction, ax will be equal to d by dt of vx. Okay. And I know that vx is, where is that vx, guys? Okay, vx is here, 500 by x times 10. So vx is 500 by x times 10. And then I need to take the derivative of this one with respect to time. Okay, then it will be that. So I will write then dvx by dx and then dx by dt using chain rule. So you may ask, why do we use the chain rule? The reason that we use the chain rule is that the function itself is not explicitly shown as the function of time. So it is shown as function of x. So what it means is that I need to move in steps. First I need to solve it as a function of x. Then x I can solve as a function of time because I know it is velocity. First one, it will be that 5000, then d of dx of x to the power of negative 1. It will be negative 1 x negative 1 minus 1. So negative 5000 times x to the power of negative 2, it will be x squared, times the dx by dt is vx. This one is the vx. Okay, then I will do that. It will be 5000 by x. Okay, and then the question says that, let me just put it here, overall, then 5 times 25, 10 to the power of 6 by x to the power of 3. It says that the y is 100, and then I know that x value in that case was 316. Then it will be that negative 25 times 10 to the power of 6 divided by 316 to the power of 3. Okay, let's solve it. 25, then you will have 1, 2, 3, 1, 2, 3, divided by 316, divided by 316, divided by 316. Okay, so it will be that negative 0.79 meters per second squared. So what it means is that the body decelerates in x direction, so the velocity decreases in x direction, but the velocity increases in y direction. So if you look for the acceleration, your y acceleration is 0. There is no acceleration in y direction, but the body decelerates in x direction. This is what the result says.